Hello, people. This is method number 2 of finding derivatives of inverse functions. And so in method number 2, we use when we try to find the inverse function, but it's not possible to find the inverse function. And example 3 gives us a pretty good situation where that happens. So if I try to start off example 3 the way I started off example 1 and 2, which was, remember, f of x is the same thing as y, and I'm going to switch my x, interchange and switch my x and y values. So this is variables. X equals y to the third plus 2y plus 1. The issue is I cannot solve for y like I did before. I have two terms with a y, and now I'm stuck. And so the way we're going to get around this is by using implicit differentiation. So if you recall, implicit differentiation helps us find the derivative without having to solve for one of the variables. So we're going to take the derivative with respect to x of this side and the derivative with respect to x of the other side. d plus d dx of 1. So we're saying we're going to take the derivative of that equals the derivative of that plus the derivative of that plus the derivative of that. And that's going to help us find what we need. All right, the derivative of x is just 1. Boom. Done. The derivative of y cubed with respect to dx is 3y squared times dy dx plus the derivative of 2y with respect to x is 2 times dy dx, and the derivative of 1 with respect to x is just 0. So I really don't need to put that last part, but I'm just putting it there to remind you that there were 3 terms, so there are 3 different derivatives that we took. But I'm going to go ahead and erase it since it's not necessary. And then we do what we normally do, which is factor out dy dx. And you're left with 3y squared plus 2. And then all of that equals 1. And then we divide by the parenthetical expression, whatever's inside the parentheses. So 3y squared plus 2 is divided into 1. And now we have our derivative equation. Except it's in terms of y. And our input, or our value that they want us to find, is at x equals 1. Well, I'm going to have to find the y value when x equals 1. So we said f of x is the y value, so y equals 1 cubed plus 2 times 1 plus 1. 1 plus 2 is 3 plus 1, that's 4. So my y value is 4. That's the number I need to substitute in here to figure out the derivative of y, which is the derivative of the inverse function. I'm going to substitute a 4 in there, and that would be the derivative of y with respect to x, where y is the inverse function. Okay, so therefore dy dx at x equals 1 is, let's see, I have to do exponents first. So 4 squared, that's 16. And then I have to do multiplication. 16 times 3 is 48. And then I can add 2, and that's going to be 1/50th. This is the value that I'm looking for. This is the derivative of the inverse function of f at x equals 1. Notice that I had to plug in a 4 into the inverse function because it was in terms of y. That seems doable. Let's look at the next one, and let's see if we can solve for y, if we can switch the variables and solve for y. If we can, then we're good. So I have to rewrite it. X equals e to the 2y plus 3y. I have two terms with a y. To make matters worse, one of them is in the exponent. So yeah, I can't solve for y. So we're going to have to take the derivative implicitly. Okay, so I'm going to take the derivative with respect to x of this side, and I'm going to set it equal to the derivative with respect to x of the first term plus the derivative with respect to x of the second term. And that would be the derivative of x, the derivative of e to the 2y, and the derivative of 3y. Let's put a plus here, yeah? All right, the derivative of x is just 1. Done. The derivative of e to the 2y is e to the 2y times 2, because I'm doing a chain rule, times dy dx, because I'm taking the derivative of something with a y, but I'm doing it with respect to x, so I have to treat it as an inside function, plus the derivative of this would be 3 times dy dx. Like before, I'm going to factor out a dy dx. I'm left with 2e to the 2y plus 3. And all of that equals 1, by the way. Let's divide both sides by the parentheses. When we do that, we're going to get 1 over 2e to the 2y plus 3 equals dy dx. But once again, I'm given an x value, but I need a y value. So let's find out what g of 0 is. E e to the 2 times 0 plus 3 times 0 . Oh no. Oh no. I'm going to save this video. We're not going to let it die. We just need, there you go. We just need more power. All right. I was running out of battery. E to the 2 times 0 plus 3 times 0 would be e to the 0 is 1 plus 0, so that's 1. That's the number I need to plug in into my formula to figure out the derivative. So it's 1 over 2e to the 2 times my y value plus 3. But my y value was 1. And so therefore my final answer is that my derivative is 1 over 2e squared plus 3, and that is dy dx. If you saw the video get a little funky there, I was losing battery, but I just charged it up so that we can finish this problem and we can get to the derivative of this inverse function without having to find the inverse function. And that's what method number 2 tells us. We can take the derivative implicitly in order to find the derivative of the inverse function.